shape or tetrahedral bonding arrangement or tetrahedral whatever on a flat piece of paper. And what we want to do is we want to put as many things as we can in the plane. That means we have fewer things sticking out and sticking in. But the things that are sticking out and sticking in, we want to make sure we get the orientation right. And so oftentimes this is what I see. You know, I see people draw tetrahedral like this. One, this is not right, because if I got rid of that, what does it look like? Trigonal planar. Is tetrahedral, do we have 3 of those sticks flat in a plane? Is it even possible? It's impossible. So one of those sticks has to project out of the plane. And so this is a very common mistake in tetrahedral. Extremely common. You've got to wedge one of these, or shade it, or do whatever. Actually, let's do orbitals, you know. Do orbitals. And so in terms of orbitals, it would look like this. 2 in the plane, that's all we can fit. And then 1's got to stick out of the plane like this, and then 1 sticks in. Now the other most common error that people make is they get the orientation wrong. And so, for example, now they have a wedge and a dash and 2 in the plane. So they put 2 in the plane, 1 coming out like this, but the 1 going in the back they have pointed up. Now what I want you to do is I want you to orient the model on your paper and then put 2 of the sticks in the plane and then see how the other 2 sticks line up. Does one project down and out of the page and the other project in and up? Is it in and up? No, it's impossible. It goes in and up. It has to go in and down, right? And so it's got to be drawn like this. This is not acceptable because this is tweaking the structure. And so what we want to do is we want to just make sure we can draw a decent representation of a tetrahedral arrangement, which is either of these 2 here. Okay. All right, so with that said, I want you to continue with this. After you're done with ammonium, I'm just going to go by and check these. Then start on amide. And so ammonia is kind of interesting. We have ammonia, which is a weak base. We have ammonium, which is a weak acid. And then we have amide, which is a powerful base. And let's take a look and see how the charge is distributed in those. Now, ammonium is also interesting in terms of polarity. Somebody might ask, is ammonium polar or nonpolar? And so let's see if I have the electrostatic map of ammonium available here. Electrostatic map of ammonium we can generate in the computer lab, and actually that's the other thing. We could generate that quickly without much difficulty. Okay, here's our standard. Red is negative charge, blue is positive charge. Standard. That's ammonia. Oops. Well, ammonium we're going to generate in the computer lab. Actually, when do I have the computer lab scheduled? Let's schedule. Well, later on. Okay, start working on amide. And then I'll swing by and take a look at that.